ICSE Mathematics Class 10th, Chapter 13, Exercise 13b. Question number 13. Find the point on a given straight line equidistant from two given points. See the question number 13. Let L be the given straight line and P be a point on it. P is equidistant from two given point A and B. देखिए केस 1 में लाइन L दिया हुआ है. There is a point P on this line and there are 2 points A and B. A and B which are equidistant from the point P. Means PA is equal to PB. The point A and B are on the same side of the line L. Case 1 में on the same side of the line L such that PA is equal to PB and L is not parallel to M. This line is known as the line joining the AB has been indicated by a line M and the line which is given, that is L. So while we produce this line, somewhere it will intersect if it is going in this direction, or if we go in this direction it will not intersect the given line. Now the case 2. Point A and B on the opposite sides of the straight line L such that PA and PB are equal. This implies that the line L is not a right bisector of AB. A and B, though the PA and PB are equal. But if you join AB, then P is not the right bisector. P does not lie on the right bisector of it. Means if you join AB, the angle made by P, let the point be here the CA and PCB will not be equal to 90 degree. That is why I have written here the point A and B are on the opposite sides of the straight line L such that P and PB are equal. The distance from P of A and PB are equal. It is already given in the statement at the initial stage. So this implies that the line L is not a right bisector of AB. Now the third case, that A and B points are there on one side of the line L and P and PB are equal. But if you join AB and produce it, it will be parallel to the given line. It will be the parallel to the given line and it will not intersect the given line. It will not intersect the given line. Now in the fourth case, A and B are on the opposite sides of line L and PA and PB are again equal here, but AB is perpendicular to the line L. AB is perpendicular to the line L. L is the right bisector of AB. You can say other way that L is the right bisector of AB where PA and PB are equal. You see, in this question it is already mentioned that find a point P on the given straight line equidistant from the two given points. दो two given points कौन कौन से हैं? A and B. हमारे को एक पॉइंट P का लोकेशन निकालना है, लोकस निकालना है such that the PA and PB are equal. But here the PA and PB are equal, but if you produce this line further, it will intersect somewhere only in one direction. So now proceed to the question number 14. Question number 14 state that find a point equidistant from the arms of the given angle and also the equidistant from two given points. अब देखिए यहाँ पर एक एंगल दिया हुआ है, एंगल AOB, और हमारे को we have to find a point which is equidistant from the arms. Arms, what is the arms? That is AO and BO are the two arms, OB and OA. OB and OA are two arms of the angle AOB. If you draw perpendicular from this angle bisectors anywhere, so you will get that the perpendicular distance means always the distance is taken perpendicular distance. So all the points are equidistant. The point lies on OC. OC, what is OC? OC is the angle bisector. So all points which lie on the OC are equidistant from the arms. Now here the two separate points are given. That is, let X and Y are given. So this line segment XY, the point which lie on the right bisector, of the given segment XY will be equidistant from the X and Y. So QR is a perpendicular bisector or right bisector of XY. The intersection of QR and OC is Q. So Q will satisfy all the conditions. Means if you drop a perpendicular to the arms, that will be also equal from if you drop perpendicular to arms OA and OB, that will be also equal, and this point is XY is given, that is Q is also equidistant from X and Y. You see, angle AOB is given. Draw the angle bisector OC. Every point on OC is equidistant from the arms, that is OA and OB. Example great here. Take a point P on OC, draw a perpendiculars to OA and OB, that is PM and PN are the equal. There are two other points X and Y given. QR is the right bisector of the segment XY, which intersect OC at Q. Hence, Q is the required point, which is equidistant from the arms of the angle and the points X and Y. Now the 15th question. State the locus in a space of point which are at a distance of 3 cm from the given point O. Same B part, at a distance of 3 cm from the given straight line. C part, equidistant from the two given points A and B. So first question is, let us state the locus in a space of a point which are. So here we have to emphasize, emphasis has been given here that in the space, I have underlined it, in the space means you have to think three-dimensional picture. State the locus in space of point which are at a distance of 3 cm from the given point O. O is point is given. So we have to find all the points, or you can say the locus of the point, which are equidistant from the given point O in space. Space means surrounding, just like a football, volleyball, or any spherical shape. So at a distance of 3 cm from the given point, it is the sphere whose radius is 3 cm, as all the points on the sphere surface on the surface of the spheres are equidistant from O, that is 3 cm. Means the locus will be all the points which will lying on the surface of the sphere will be equidistant because it is given already in space. Now they come to the B part of it. A distance of 3 cm from the given straight line L. There is a point, there is a line L, and 3 cm away. All the points, we have to assume that all the points. So all those points which lie on this cylindrical part, curved surface area or curved surface, will be equidistant from the axle. Axle means axis of the cylinder, that is this line which has been indicated by line L, axis of the cylinder I have mentioned here. The point which lie on the curved surface are equidistant, that is 3 cm from this axle or axis of the cylinder. So point lie on curved surface area of a cylinder, radius 3 cm, where line L is passing through the center of the cylinder. So the B part is over here. Now come to the C part of it. Equidistance from two given points A and B. We have to find the points in space. Equidistance from two given points A and B. A and B are given. So we have to find the points which are equidistant in space, especially I am telling. So all the right bisector plane of AB line segment. This is a AB line segment. So any plane which is cutting the AB segment rightly, perpendicularly, and the point containing by this plane will be equidistant from A and B. Now come to the 16th part of it. State the locus of a point P which moves in a plane through two fixed points A and B so that PA is equal to PB. Okay, question number 16. State the locus of a point P which moves in a plane through two fixed points A and B so that PA and PB are equal. In a plane, you see, in a plane means suppose the paper is a plane. Paper is one of the plane. So this point P, locus of the point P is the right bisector of AB. So I have just indicated the path of this point. The point path, that is locus. It is a perpendicular right bisector of the line segment AB, or perpendicular bisector of the line segment AB. This will be the figure. Now come to the D part of it. State the locus of the center of a variable circle of radius 1 cm which touches externally a fixed circle whose center is E and the radius is 2.5 centimeter. There is a fixed circle. I have written here fixed circle, that is whose center is E. There are variable circles which are revolving or rotating and touching the surface, means what is called circumference of the circle, whose radius is 2.5 centimeter. And there are variable means many circles which are moving, having the radius r, center r, and a radius equal to 1 centimeter. So what will be the path covered by the r? R means the center of the circle. And all these circles are having radius equal to 1 centimeter. So just to add 1 centimeter to 2.5 centimeter, you will get other concentric circle whose center will be E, and it will be just outside, where the small circle having the radius 1 centimeter will keep on moving in such a way that it touches the surface of the circle E. You see, state the locus of the center R of variable circle of radius 1 centimeter which touches the externally a fixed circle. What is fixed circle? The circle, inner circle, that is whose radius is 2.5 centimeter, whose center is E and the radius is 2.5 centimeter. Answer: the locus of R is a circle whose center is E. Center will be E and the radius will is 2 plus 2.5 plus 1, that is 3.5 centimeter.